This video is about the psychology of AI, how machines learn and adapt to human behavior. With machines' ability to handle enormous amounts of data and perform complex tasks, artificial intelligence has become an increasingly important element of human life. But how do machines learn and adapt to human behavior? In this video, we will look at the psychology of AI, how it learns, and how it affects our life. Before we begin, don't forget to subscribe to our YouTube channel Cajun World. Let's look at 10 examples of how machines learn and adapt to human behavior. 1. Supervised learning. Supervised learning is a machine learning technique that uses labeled data to learn. Labeled data is a dataset that has already been classed or categorized, and the machine utilizes it to learn how to categorize new data. A dataset of images of dogs and cats, for example, can be used to train a machine learning algorithm to classify new images as either dogs or cats. The labeled dataset is split into two parts: training and testing. The training set is used to train the machine learning algorithm, while the test set is used to assess the algorithm's performance. Supervised learning is widely used in many applications, but it requires a large amount of labeled data to train the algorithm, which can be time-consuming and expensive to collect. 2. Unsupervised learning. Unsupervised learning is a machine learning technique that uses unlabeled data to learn. It can help with tasks like clustering, anomaly detection, and dimensionality reduction. It can aid in the identification of patterns and relationships in data that are not readily obvious to the naked eye. However, it might be difficult to evaluate the success of unsupervised learning algorithms due to no labeled data to compare the findings with. Furthermore, training the algorithm necessitates a big amount of data, which can be difficult to obtain in some circumstances. 3. Reinforcement learning. Reinforcement learning is a machine learning technique that involves getting feedback from the machine's activities. A robot navigating a maze to find a prize, for example, would do different actions and earn a reward or punishment based on the action taken. The robot's purpose is to learn a policy that maximizes the reward. Reinforcement learning is utilized in a variety of applications, including robots, gaming, and autonomous driving. However, designing a reward function that precisely reflects the desired behavior can be difficult, and the learning process might take a long time to converge. Furthermore, training reinforcement learning models necessitates a large number of computer resources, which can be costly. For neural networks are a type of machine learning technology that is inspired by the structure and function of the human brain. They are a deep learning algorithm that entails constructing a network of interconnected nodes or neurons capable of learning to detect patterns and make predictions. The neural network is made up of several layers of neurons: an input layer, one or more hidden layers, and an output layer. The weights and biases of the neurons are modified during the training phase to reduce the error between the predicted and actual output. Many applications use neural networks, including image identification, audio recognition, natural language processing, and predictive analytics. They are, however, computationally expensive to train and may necessitate vast amounts of data to avoid overfitting. 5. Natural language processing. Natural language processing (NLP) is a branch of artificial intelligence that focuses on enabling machines to understand, interpret, and generate human language. NLP is used to build systems that can analyze, process, and generate natural language text or speech. NLP natural language processing is a difficult field that analyzes and generates natural language data using techniques such as statistical modeling, machine learning, and deep learning. Many applications use it, including chatbots, voice assistants, sentiment analysis, and machine translation. NLP algorithms must be able to handle variations in grammar, syntax, semantics, and pragmatics, as well as comprehend human communication nuances. They must also be able to manage vast amounts of data, as linguistic data is frequently unstructured and noisy. 6. Sentiment analysis. Sentiment analysis is a branch of natural language processing that employs computational algorithms to detect and classify the emotional tone or sentiment of text. It is used for a variety of purposes, including social media monitoring, customer service, product reviews, and market research. Sentiment analysis algorithms classify the sentiment of a piece of text using machine learning techniques such as supervised learning or deep learning. However, due to characteristics such as sarcasm, irony, and context, sentiment analysis can be difficult. Furthermore, due to differences in linguistic structures and cultural nuances that affect sentiment, sentiment analysis algorithms may not perform well in languages other than English. 7. Behavior analytics. Behavior analytics is a field that analyzes and interprets trends in human behavior using data science and machine learning approaches. It entails gathering and analyzing data from a variety of sources, including social media, website traffic, and mobile devices, in order to acquire insights into human behavior. To study and evaluate human behavior, behavior analytics algorithms employ a variety of approaches such as clustering, anomaly detection, and predictive modeling. It can be difficult since human behavior is complex and varies widely in different settings. However, while collecting and analyzing data on human behavior, it is critical to guarantee that privacy and security concerns are addressed. 8. Predictive modeling. Predictive modeling is a technique that analyzes historical data and makes predictions about future occurrences or trends using statistical and machine learning techniques. It has a wide range of applications, including risk assessment, fraud detection, and demand forecasting. Predictive models can employ a variety of techniques to construct models that can predict future outcomes, such as regression analysis, decision trees, and neural networks. Despite these obstacles, predictive modeling can provide useful insights into future events that can be utilized to drive corporate decisions, optimize operations, and decrease risks. 9. Contextual intelligence. Contextual intelligence refers to machines' capacity to comprehend the context in which data is provided and use that knowledge to make more accurate and informed decisions. It entails examining and interpreting data in the context of its larger context in order to acquire a better grasp of its meaning and relevance. Contextual intelligence algorithms can examine and interpret data in its broader context using techniques such as natural language processing, sentiment analysis, and machine learning. Can be difficult because context is extremely subjective and varies widely depending on the user's background, culture, and personal experiences. Contextual intelligence can provide important insights into the meaning and value of data, which can be used to inform decision-making, personalize experiences, and increase prediction and suggestion accuracy. 10. Machine learning algorithms. Machine learning algorithms are computer programs that learn from data and make predictions or choices without being explicitly programmed to do so using statistical and mathematical methodologies. There are 3 types of learning: supervised learning, unsupervised learning, and reinforcement learning, as we mentioned before. Supervised learning is the process of training a machine learning model using a labeled dataset, where each data point corresponds to a certain output or label. Unsupervised learning entails training a machine learning model on an unlabeled dataset, with the model tasked with discovering patterns or structures in the data without any explicit instruction. Reinforcement learning entails teaching a machine learning model to make decisions in the presence of feedback in the form of rewards or penalties. Despite these obstacles, machine learning algorithms have the potential to be strong tools for solving complicated issues such as image recognition, natural language processing, and predictive modeling. Machine learning algorithms enable computers to adapt and learn from their environments by learning from data and making predictions or judgments without being expressly programmed to do so, making them more intelligent and capable of interacting with humans in more natural and intuitive ways. The psychology of AI is a complex and rapidly evolving field. Machine learning algorithms allow machines to learn and adapt to human behavior, but they also raise important ethical considerations. As AI continues to become more integrated into our daily lives, it is important to be aware of its capabilities and limitations. By understanding the psychology of AI, we can better understand how machines learn and adapt to human behavior, and make informed decisions about its use. Thank you for watching the video fully. Don't forget to like and share. We'll be back with another interesting video very soon. Thank you.